So, hello guys, welcome back to Geeks for Geeks practice channel. And today we'll be discussing another DSA problem. My name is Dhananjay Mishra, and today in this live session we are going to discuss another DSA problem which was recently asked in Morgan Stanley. So, it is a problem which is based on linked list. So, the data structure we'll be using in this problem statement will be a linked list. So, before moving further, let me ensure that whether my voice is audible or not. So, can you please acknowledge that if my voice is audible to you or not? So can you please let me know whether my voice is audible to you or not? So can you please let me know whether So yeah, okay. I think my voice is pretty much audible and video is pretty much visible too. So let us now begin with the problem statement we will be going to discuss in this live stream. So the name of the problem statement is delete without head pointer. It is a very famous question to be asked in a linked list. And if anyone wants to begin with linked list, so it is a pretty much good question to start with the topic of linked list so that you can get your hand set on the traversals of linked list, how to traverse a linked list, how to traverse a singly linked list especially, and how to deal with the next pointer, the values, the reference, and all in the linked list. So the name of the problem statement, as I said earlier, is that delete without head pointer. So basically, in this question, you are given a pointer or a reference to the node which is to be deleted from the linked list of n nodes, right? So the problem statement says that we are given a linked list, okay, and the node we have to delete in this linked list, we are only given the pointer to that node only. The task is to delete that node. Pointer reference to the head node is not given. So basically, if I remind you that when someone asks us to delete a node or a particular node in a linked list, giving us the reference or that address to that linked list which has to be deleted. So basically, we are given a head of the linked list, that is the start node of that linked list, right? Because to traverse a linked list, we need the head pointer of any linked list so that we can traverse to that node and we can delete that node, which is like, and let us discuss how we do if a head of a linked list is given to us. So basically what we do in that case, uh, we just let us consider that if this is my linked list, okay, and I have to delete this particular node, right? I have to delete this particular node, and in the case if head pointer is given to us, unlike this case or this requirement or this task given to us, in when we normally have to delete a node in a linked list, that is if we want to delete this node in a linked list, for example, then we are given a head pointer, this pointer, and we stop a node previous to the node which we have to delete, and then we shift the next pointer of that node to this pointer, right? So this is how we normally do when we are given a head pointer, but in this case we are not given any head pointer to traverse to the node to be deleted. So this is the main issue, right? So this is the main hindrance which is given by the interviewer or this problem statement to us. So again, if we read the problem statement, it says that no head reference is given to you. It is guaranteed that the node to be deleted is not a tail node in the linked list. So that means that the tail node in the linked list means that the last node, right? So it is guaranteed that we won't have to be deleting the last node, or this node also clears another doubt that we will be having a linked list of size greater than 1, because if the size of linked list is equal to 1, then this node itself, or the node itself, is a tail node. But we are given that the node we have to delete will not be a tail node, right? So the size of our linked list will be greater than 1, and if the size of the linked list is greater than 1, then we will have to be deleting the node in this range, not the last node. Okay, so I hope the question is pretty much clear to you. And now let us now look at a sample test case to just check that what kind of task we have to perform and what kind of answer we have to return. So we are initially given n equal to 4, that is the size of the initial linked list, and after that we have to delete the node number 20 which is assigned to us. That is the value of the node is given to us, not the reference or address of the node. We are given the value of the node which is to be deleted, right? Because in a linked list each node have two values, right? That is two values, I mean two entities. One is the value and one is its next pointer. So if I draw it in a bigger size, then linked list is having two entities. One is the value that defines the what kind of data is stored in that node, and another is the next pointer, that is to which next address or which next node it is pointing to in a linked list, right? Because it is dynamic allocation unlike array. Okay, so this is all about the basics of linked list. So after deleting 20 from the linked list, we have remaining nodes as 10, 4, and 30. So it is pretty much obvious that if we delete the node number 20, then the linked list left with us will be 10, 4, and 30, right? So in the initial linked list, if I draw the initial linked list, then the initial linked list given to us was 10, 10, and 24. Okay, 10, 20, 4, and 30. So this was the initial linked list which was given to us. Okay, and now we have to delete this linked list. So after removal of this node from this linked list, the final answer, the final node or the final linked list we have to return will be 10, 4, and 30. Right. So this is the visualization of what our final answer will look like, and this is the visualization of how our initial linked list is given to us. So basically, we are given this, we are given the node or the reference to the node to be deleted, right, in the function parameter. So right, yeah, that's the case. So we discussed earlier that what would happen if we were given a head pointer to that linked list. So this is the normal general question we study when we start studying the linked list, that how to insert a node, how to delete a particular node with a given reference. So in all these cases, we are initially given the head pointer for our easiness, so that we can traverse back to that particular position and we can perform the task which we are required to do. That is, in the case if we want to assign a node or to add a node at that particular position, so we reach out to that position with the use of the head pointer by traversing. Or in the case if we want to delete, then we again use the head pointer for traversal, and then we reach at that particular node we have to delete, and then we delete that node. Okay, so let us now, this was the case when we were given the head pointer, but in this case we're not given any head pointer. We are only given the reference or the address to the node we have to delete. So I hope I'm sounding logical and more clearer to you now. So yeah, so let us now discuss the how we can delete a node in a linked list in a general normal case, right? So basically there are several methods to delete a node in a linked list, right? So if I say that we can also use the free method, right, or to delete, right, delete method to delete a particular node or to free the address or the memory allocated at that node. But the another case or the another easiness we can use is that another method what we can apply is that, suppose this is my linked list, right? So what I do, instead of using the free function on that particular address or delete function on that particular address, what we normally do is that, suppose if this is my linked list, okay, let's consider this is my linked list, and now I have to remove that linked list. So the in linked list, what happens is that everything or the every node we connect is connected by the only single source, that is the next pointer, right? So I hope what I'm trying to say is pretty much clear to you, that every node in the linked list is connected by the next pointer. So basically, if there were no next pointer, our linked list would look like something like this, right? So there would be nodes lying all around here, and there is no connection between those nodes. So with the help of next pointer, we assign and make a chain, and we define an order in which the linked list or the nodes will be connected in a linked list, right? So order is like this in this case. So basically, if I say that I want to remove a linked list, so what will I do? So you can like you can guess that now after studying the next pointer and the logic of the next pointer, if we change the next pointer of the previous node to the next pointer of this node, right? So let me take a fresh page and again discuss it with you. So what I'm trying to say is that, let us suppose this is my linked list. Start from beginning. So if this is my linked list having certain number of nodes, right, and I have to delete this particular, let us say this particular node, right? So we discuss how the next pointer and what is the significance and importance of next pointer. So what I can do is that instead of using the free or delete function to free this address or memory allocated, I will just normally come at this node and allocate the next pointer or point the next pointer which was pointing to this node to now this. So the next pointer of this node will be pointing to this instead of this. So automatically, if this node or this pointer is allocated is removed from allocation to this node and now it is put to allocation to this node. So this node will automatically be free, right? So our linked list will look like this now, right? So one node is being deleted because although this node will be pointing to this, but there is no chain found because the chain is broken, as the previous node which should be pointing the previous node's next pointer which should be pointing to the node is now being pointed to the next node, right? So that this chain is broken, so it doesn't matter that if this particular node is pointing to this node or not. The chain has been broken, so now the final linked list will look like this. This node is being removed. So this is the visualization how we can do that. So in the questions of linked list, everything resides on the way you visualize, because once you visualize what you have to do, you can easily code anything, right? So the main part in this linked list is visualization. So this is one method to remove a node. Okay, another method to remove the node is the extension of this part only, right? So what we can do, that we were given a value, right? Suppose if I want to remove this node, okay, so what I can do is that the next pointer of this node, suppose I want to remove this node, okay, let us say I want to remove this tail node. So what I can do, the basically what I can do is that we have to only deal with the next pointer. Like we have got an idea that after studying the property or the importance of next pointer, that in case you want to delete a node, we can only use the next pointer and we can delete any particular node, right? Any particular node, right? So if I want to delete this tail node, what I can normally do, I can come back, I can start traversing to this node in case head pointer is given to us. And in case I'm repeating again, in case the head pointer is given to us, but in this section only we are discussing only about, or we are bothered only about how to delete a particular node. We'll come back to the point when no head pointer is given to us, but in this part or in this phase of this live stream, we are only discussing about, or we are only bothered about how to delete a particular node. So if I want to delete a particular node, let us say I want to delete this node. So I will come back, come back, I mean I will traverse till the n minus 1 node. Suppose it is the n node, I will traverse till the n minus 1 node and I will point the next pointer to be null of this next pointer, right? So this node is pointing to this node, but instead of allocating the next pointer of this node to the next node, I'll be simply pointing it to the null node. That so the null of any linked list denotes that the linked list is over now, right? So there is no more chain again left. So by allocating it to null, we are shifting the next pointer of this node from this to null. So that means this node is now being freed. It is lying in the free empty space, right? It is lying somewhere in the free space and it is not part anymore part of this initial linked list. So this is another method we can do, right? So we will use this second method to do our, or to do or complete our task, right? So let us see how we'll do that. So let me draw that initial linked list again, 10, 20, 4 and 30. Okay, so I was determined, I was asked to delete that particular this 20 node, right? So and I was given a pointer to that node. So what I can do is I cannot basically I can traverse starting from this node only because head node is not given. So we have to drop the idea of the first idea we discuss of deleting a node, that is traversing from the initial node. I hope that logic is clear because the head node is not given to us. So now we are left with only two choices, right? We can swap the values and delete. By swapping the value we have to delete will make that value point to the By swapping, we will make that value in the last node. Okay, so let us see the iterations we'll be doing. I will be swapping these values. So 4 will come, 20 will come here. In the next, this is the first iteration. In the second iteration, again I'll be doing swapping. So 30 will come here, 20 will come here, right? So if I'm pointing at this, I'm swapping with the next, the value of the next node, right? So after first iteration, I'm still pointing here. Then I will in that particular, in the same iteration, I'll point to this node. So in the next iteration, so therefore with the help of this, in the next iteration, I can swap the next node's value, right? So I'm pointing here. So now, as we saw that here, if I want to delete that last node, I will just point it to the previous node's next pointer. I'll point it to the null, as we discussed here, right? So we are using that concept. So yeah, so we are pointing here in the second iteration, and we will point this next pointer to be null. So basically our final answer will look like this, right? And the last will be pointing to a null. So the concept of null is pretty much also important in case if you want to delete any linked list, right? Or to shift or break any linked list, to break any chains. So the concept of null is that the last node of every linked list always point to null. Null signifies that there are no more further nodes in the linked list. So if you encounter any null, that means that this is the end of the particular link. So we are using this fact and importance of null to our benefit to remove a particular node, right? So this is the first method. The time complexity of this method will be the size of the linked list, because in the worst case we can travel the complete or all the nodes. So this is the one method, right? So in this method, if I add the pseudo code of it, so what we'll basically do, we will iterate while, so what we did that we were only traversing till the point we are reaching the second last node, right? So the condition to traverse only to the second last node is while nodes next, suppose if I'm pointing here, so the node next will point to 20 and 20's next will be null, right? So while node next not equal to null, right? So this is how we will use the condition to reach till the second last pointer. We don't want to reach the second to the last node. So to reach till the second last node only, we use this condition. So let me again explain what this condition means. Nodes next. So if I'm pointing here, the nodes next is 20, okay, and the next of this node is 20, right? So what I can do to determine that this is my second last node, this is the condition to determine that I am at the second last node. That is node next. The next of nodes next is not equal to null. So that means that if I'm pointing here, for instance, I'm pointing at this node. Nodes next is 30 and this next is 20. So it's not null, right? So we are not pointing at second last node. So this is the hard code or dry run we did to ensure that yeah, we are doing the right manipulation on this linked list, right? So after that, we will be swapping the values. That is, we will swap the nodes value I'm currently pointing at and nodes next nodes value. So by doing this, we'll be swapping the value. That is what we did here. So 4 will be swapped to 20. And after that, I have to point to the next node, right? So I will do node equal to node next. If I don't use this, it won't give me a run TLE, because we are not moving in the next, we are not moving ahead. So this loop, if we didn't use this condition is crucial. Sometimes we miss in panic or hurry. So we have to take care of this condition to move forward in the linked list, else it will give me a time limit exceed. Okay, so this is the first approach, and the time complexity of this approach is big O of size of my linked list. Okay, so I hope this first approach is clear to you. Okay, now let us talk about the second approach. So the second approach also, so this thing should be clear to you by now that we can't normally delete because we are not given the head pointer. So we have to do some other things, like we are only left with the option of swapping. right? We have to swap such that we can delete that node by doing some manipulations and smart tricks, right? So the second approach is that suppose this was my given linked list. Okay, this is 30, and I have to delete this particular node. So what I can do, instead of traversing all the node, the first approach that we discussed, that we only have to change the next pointers in such a manner that the node to be deleted, the node to be deleted, and the node and the previous pointer of the node which is to be deleted now points to this, right? This is what we have to do, right? So we have to do it in some smart manner, because we cannot, this is a singly linked list, right? Just to remind you that again, that that this is a singly linked list, and we, to do this approach, what we discussed in the first approach, we have to come a node back to the node we want to delete, right? So if I want to delete 20 node, then I have to be pointing at the previous node, right? So if I'm pointing at the previous node, then only I can point the next pointer of this particular node to be the next pointer of the node we want to delete. So this is the only way we can shift the next pointer and delete that node. But if I want to delete that node and I don't have any access to the previous node or the node I want to delete, what I can do is that I can normally swap the value of these two, so that my node or my linked list will look like this, right? So now I'm pointing at this node, right? And now I want to delete this node. So basically, if I want to delete this node, and I have a pointer which is, or the node reference to the node which I want to delete, that is the previous node, right? So this is now the previous node, and the node we want to delete is 20. So we somehow use the tricks, and we reached out to a stage, uh, and the phase of that stage we can utilize to remove that linked list, remove that particular node, right? Because if I want to read that node, I have to be at the position which is the previous to the next node. So 4 is the previous node, just previous node of this 20 node, right? So I can shift that next pointer of this node to 30, right? So in this manner 20 will be deleted. So let us now look how this will look by if I visualize. So in the first step, okay, this is my linked list, 20, 4 and 30, right? So in the first step I'll be swapping these values. So my linked list after first step will become this, right? So now instead of traversing till the last, what I'm doing smartly is that in the second step, we know that we can remove a linked list by shifting the next pointer, right? If I want to delete that node, so I have to delete a node by using the next pointer. I have to be in a position just the previous node, right? So 20, if I want to delete node number 20, node with level 20, then I have to be pointing at the previous node, right? So I'm pointing at this previous node because I have not shifted the next pointer, or I have not moved to the next node after the first step. So yeah, I'm pointing here. Now in the second step, I'll be just shifting the next pointer of the node number 4 to 30. So my linked list would look like this, and right. So yeah, so the continuous chain is now broken, and 4 is pointing to this. So this doesn't mean anything, right? So we can again rearrange the node, and this is more logical, right? So this is our final answer, and this answer I have to return. So the time complexity is big of 1, because we are using only one operation of the swiping and then shifting the next pointer. So this is pretty much so good looking, because it is a small code and we can use our coding skills, right? So the interviewer will be pretty much impressed if you do this approach instead of doing the normal approach of shifting or swiping the values till the last nodes, right? So I hope all the approaches are pretty much clear to you, and now we will be moving to the coding part of both of these approaches, right? So guys, okay, sorry guys, sorry for the delays, that the screen was not visible. Okay, so we will discuss again. I hope my screen is visible now. Please ensure that whether my screen is visible now or not. Okay, so sorry for that technical issue I had because of what I was not able to display site. So So let us now discuss again, right? All the approaches we did, we will discuss it again so that in the manner you can understand that, right? So yeah, so we have to, in the question, we have to be deleting a node. So this was my initial linked list. I'm taking a sample test case example. I have to delete a node without, I have to delete a node in this linked list without using the head pointer. That means I was not given the head pointer, right? So and I have to delete a particular node. So in the normal case, if I want to delete a linked list, I would be I would be given a head node, right? So head node in this case will be 10, and with the help of that, I can remove the node I want to delete, right? So in the case, if in this case, if I want to delete a node, if I want to delete a node number 20, so my final answer will look like this, right? So how can I do that? In the general case, if I would be given a head node, then it is the normal thing that, or the normal logic we use, that we iterate till the previous node which we have to delete. So suppose if I want to delete the node number 20, or if I take another example or certain another nodes, and now in this case, if I want to delete that node, this node, so if in the case, if I was given a head node, the pointer to the head or the reference or address to the head, then I could have been traversed till the this node, a node just previous to node that I want to delete, and I can shift the next pointer of this node to this node, right? So because if I want to delete a a node in the linked list, there are certain ways to do that. One way is to do that I can use the delete function to free the space allocated to the node I want to delete, or the free function to disallocate the memory allocated to the node which I want to delete, right? So this is the one way. But instead of that, I can also do, uh, I can just shift the next pointer of that node to the next node of the node I want to delete, right? So what I can do is this. So my this node is deleted in this manner because the next pointer of this node is now being pointed to the next pointer of the node I want to delete, right? So the chain is now broken. This chain is broken. So this node doesn't mean a thing, even if it's pointing to the next node. But the continuous chain is broken, and now this chain is pointing or initialized to this node. So my final answer will be looking like this, right? So, but in this case, we are not given any head node. Okay. So if we are not given any head node, so there are two approaches we can do, right? So the thing I told you, that we can utilize the next pointer, because in a particular node in a linked list, we have two entities for each node, that is the value and the next pointer. Next pointer is used to point to the next node in the linked list, because initially if we don't have any next pointer or any chains connecting the nodes, our linked list will be looking like this if there were no next pointer, right? And now if I do the, if I join all the next pointers, so my linked list will look like this, right? So this makes sense, right? Because if I rearrange this node again, if I rearrange this node again, this linked list again, so it will look like, somewhat look like this, right? So this makes a sense. That's why we use always the next pointer in the linked list to join all the nodes which are spread all around the memory space, right? So we use the next pointer for that. No, so now we know that what's the importance of next pointer. So and how we can twist the next pointer and the importance of next pointer to, or the logic of the next pointer to our use to delete a particular node, right? So how to delete that particular node? This is the way we can delete the particular node, right? So let us now jump back the part where I discussed all of these things. Okay. So yeah, this was the previous stage where I discussed everything. Yeah, so this was the previous notes that I discussed, but due to the technical issues, my screen was not visible, right? So yeah, let us now discuss and understand from this part only, right? So as I told you that what is our task and how we can delete a particular node, right? So we can use a free function or delete function to disallocate the memory allocated, or we can twist the next pointers to delete a particular node, right? So as I told you that if I want to delete this particular node, and one more thing in this question was said to us that we will the node we want to delete will not be a tail node. That means tail node means the last node of that linked list, right? So if this is my linked list, and if I'm pointing to this node, then this node is the tail node. So we will not be asked to delete this tail node, right? So that also means that our linked list will be of size greater than 1, because if my size of the linked list is 1, that means this the only node in the linked list will be the tail node, right? So this also means that the size of my linked list will always be greater than 1. That means they will always be greater than one node. And if they are greater than one node, then we'll be deleting a node which will lie in the range from this to this, right? From 0 to n minus 1. If there are n nodes, then we will be asked to delete the nodes in the range 0 to n minus 1. I hope this is clear to you. And now we will be discussing the two methods, how to approach or how to complete the task we are given to us, right? So in the first method, as I said that we were not given any head node or head pointer, right? So what I can do, I can swap the values, right? I can swap the values, and let us see how I'll approach that, right? So if I'm not given the head node, then I cannot point to the previous node, right? Because even again I have discussed previously that if I want to delete a node using the next pointer, then suppose if I want to delete this node, this is my linked list, I'm repeating again that if I want to delete this particular node, right? So I have to be pointing to the just previous node to that, because if I'm pointing to that previous node of the node I want to delete, so I can use the next pointer and point to this. So I hope you understand the condition for deleting a node using the next pointer, that is I have to be pointing the previous node of the node I want to delete, right? So how can we do that? Because we are not given any head pointer. So if we were given any head pointer, we could have been traversed till the node or the just previous node I have to delete, right? But we are not given the head pointer, right? So and it is a singly linked list, so we cannot traverse back, right? We can only traverse in the forward direction because it is singly linked list. So I have to somehow manage to get my pointer to the node I want to delete, right? So I have to somehow manage to reach to the previous node of the node I want to delete, right? So I hope that you are getting what I'm trying to say. So how we can do that? There are two methods to do that. The first method is that I will be keep swapping my values until the value I want to delete reaches the last node, right? So in the first step, I'll be swapping the values. That is, this is my initial pointer given to me, that or the node I want to delete with value number 20, right? So I'll be swapping the values. So in the first iteration, I'll be swapping the first these two value. So the node in the linked list after the first iteration becomes like this, right? And now in the second iteration, again I'll do a swapping, right? Swapping, that means 20 and 30 now will be swapped, right? So now after swapping, so suppose if I do a one swap, then after swapping I'm not moving my next pointer. I'm currently, if I do the swap, suppose if I'm doing this swap, that is 20 and 4, and if I do the swapping, so 4 and 20 will be here. And one thing to note here is that it is a crucial thing that after swapping, my pointer is still pointing to that particular node, right? The initial node I was given. After doing the swapping, I will be swapping again so that I can move to the next nodes. But after swapping, immediately I'm not changing my next pointer. Let us now discuss why we are doing this, because if my all swaps are done and the value I want to delete is pointing to the last node, right? So as I said earlier that if I want to delete a node using the next pointer, I have to be pointing or managing a pointer such that I'm pointing the previous node, the node I want to delete. So after the last swapping, my pointer will be pointing at 30, and now we can point to the null node. So the concept of null here is that if suppose I'm having a linked list, suppose this is my linked list, the last node always point to the null. That means the null depicts that there are no further nodes available in this linked list. So this is the last node of that linked list, right? So if I'm pointing the second last node and I want to delete that node, right? So what I'll do, I'll point to the null simply, and this node will be deleted. So this is the logic we are using here, right? So after pointing to the null value, the next pointer of the second last node to the null. So my linked list will look like this, and this is the final task I have to perform, right? So let us now look at the pseudocode. How we'll be doing that pseudocode. So we have to traverse, right? We are doing traversal from the node which we were initially given to the last, right? So how we will do that? One thing to note here is that we are traversing till the second last node only, right? Because the node I want to delete will be pointing to the last node, and again I'll repeat that to delete using the next pointer, I have to point to the previous node of the node I want to delete. So if my 20 is pointing to the last node, so I have to keep my pointer at the second last node only. So I have to write a condition so that I will only traverse to the second last node. So this condition satisfies my requirement, right? So what does this mean, condition, right? What does this condition signifies? Suppose if I draw the linked list again here, let us suppose this is my linked list, right? So or let us draw the final linked list, right? The final linked list was 10 after swiping 10, 4, 30 and 20, right? So I want to delete this node. So I want to reach this node from starting, if I'm starting my iterations from here, right? So what I can do? So this condition means that nodes next. So if I'm pointing here, that means nodes next is 20 and again next. So the next of this node is null. So by this condition, I can check that yeah, I'm currently pointing at the second last node and I don't have to iterate further, right? Let us now take another example to ensure that this condition will always make us reach the second last node, right? So if I want to delete that node, so how will I ensure that I am pointing this node? So suppose if I'm pointing at this node, suppose if I'm pointing at that node, so the next of 10 is 4 and the next is 30, right? Similarly, if I'm pointing at 4, the nodes next, 4's next is 30 and 30's next is 20. So that means I'm not the second last node, because the condition for second last node, if it would have been the 4, if 4 would have been a second last node, then the next of 30 would have been null. But this is not the case, right? Because 4's next is 30 and 30's next is 20. So it is not a second last node. It is pretty much clear. But if I was standing at 30, 30's next is 20 and 20's next is null. So that means it is a second last node, right? So this is the condition for checking whether I am at the second last node or not, right? So now, as we discussed that we will be keep swiping until we reach the second last node, and we will be iterating after swiping. I'll be moving to the next node, because this condition, if I don't apply this condition, then I'll be reaching the time limit exceed, right? So this loop will run infinite times because I'm not moving forward. Let us now discuss, so after clearing all the pseudocode and all, let us now discuss the time complexity. The time complexity of this approach is the size of the linked list, because in the worst case I can travel all the nodes in the linked list, right? So now let us now discuss to the, so now we can see the uh, like the demerit of this approach is that we have to traverse, right? We have to traverse to the last node, right? So we can do it something better, because the worst case time complexity will be the size of the linked list. If there are n nodes in the linked list, so the time complexity will be go of n. But still we can do some better. There is still room for doing it better. So let us now look how we can do that. So the second approach, we will now discuss the second approach. So in the second approach, uh, that what we can do is that we will use the concept again that to delete a node, if I want to delete a node, then I have to point. I should have a pointer which will be pointing to the previous node of the node I want to delete, right? So the same concept is there, but instead of, why do we do traverse all the nodes? We can do it in over1. Let us now look how we can do it in over1. So what we'll do that in the first step. So this is my initial linked list, and I want to delete this node, right? So I'll do a swapping. Once I swap, I will be pointing at the node, this node only, right? So my 20 is now shifted to the next place. And now, as I said earlier, we have met the condition that we should have a pointer that will be pointing to the previous node of the node I want to delete. So 4 is the previous node of the node I want to delete. So normally I can now apply, or I can point this next pointer of 4 to 30, and this manner 20 will be deleted. So after doing this step, my final linked list will look like this, right? But so final linked list, let me draw it again. So my final linked list will somewhat look like this. So but this doesn't make any sense, right? So the chain is broken. It doesn't matter whether 20 is pointing 30 or not. The continuous chain is now broken. So my linked list will finally look like this. So this is how we can do. So these are the two approaches. So Let us now discuss the time complexity. So we can see that we are only doing, there are only two steps involved, right? The first step is swiping, and the second step is shifting the next pointers. So the time complexity will be obviously big of 1 because we are not doing traversal on the linked list. We are only swiping the two nodes and shifting the next pointer, right? So these were all the approaches. I hope all the approaches are clear to you, and sorry for the technical issue that I was not able to share my screen with you. But now I hope all the notes I discussed in the first attempt are, I have shared with you all those notes, and I have tried to discuss you again with all the previous notes again, so that you can get better much understanding of that. So let us now move on to the coding part, right? So yeah, so this is a practice portal where you can find many problems on the basis of company tags, topic tags, and many other tags, right? So yeah, so this is a beginner level problem for the person who's starting a linked list, and the interview might ask this question because you can normally do this task with the approach of big O of n, that is traversing all the nodes. But the main task interview wants that how can you do it something better. So the main task is, can you do it in big O of 1? So the interview is mostly interested in that part only, right? So okay, so as we can see that we are also expecting the time complexity of big O of 1 here, right? So let us now move on to the coding part. We'll be doing all the two approaches, right? So that you can have an idea how both of those approaches work, right? So we'll be discussing the first approach here. Comment it down for you. First approach, the time complexity of big O of size of the linked list, right? So yeah. So we were given the pointer to the node which we want to delete. Okay. So we will start traversal as the condition as we wrote down in the discussion part. We will implement the same condition while we can see that the data structure or the structure of the node is that in a single node we have two entities, that is data which will be pointing to the value of that node, and the next pointer which will be used to point to the next nodes in the linked list, right? So as I said that while the node I want to delete, right? So this is the node which I'm pointing to should not be equal to the null. So this is the condition for checking second last node. So I will comment it down for you so that you can connect it more clearly, right? Yeah. So as I said earlier, I'll be swapping the values of the current node's value and current node's next value, right? So this is what this line means, that if I'm pointing here, I'll be swapping the value of this node, that is node's value and node's next value, right? This is what I mean. Node's value and node's next value. And after swapping, I'll be moving further ahead in our linked list. So this is how I'll be moving in my further ahead in my linked list, right? So when this is done, I'm ensured that after this loop is over, I'll be pointing to it is guaranteed that I'll be pointing to the second last node because I've given the proof in the discuss section also, the discussion part. So now last step we are left with is that if I'm pointing to the second last node, then I have to point the next pointer to null, right? So this is what my first approach will look like, and let us now try to submit it. It is now compiled to check whether there are any issues or not. Yeah. So yeah. So the here it is data. The entity here is data, right? Data. So I did some typo. So let us. So I hope this will work now. Yeah. So now let us submit it. So this is giving me a wrong answer. So let us now discuss what went wrong here, right? So we had a next pointer, we iterated till we reached the second last node. Okay, we traversed, and once we reached the second last node, we deleted it, right? So this looks nice to me. So let me see what's the error. I'm swapping the value. It's correct. Okay. Okay. So one thing I missed that after this, I'll be pointing the second last node only, right? I have not swapped the values. I'm pointing the second last node, but I have not swapped the value. So if I look at the iterations, the first iteration I have swapped these values. So 4 and 20 will be swapped. In the next iteration, I have swapped the. So if I'm pointing here, in the first iteration, I have swapped these values, right? So I'm pointing in the next iteration here, right? So at this place, I'm in the second last node, right? So my loop will be over, and therefore I have to now swap these values, right? So yeah, so now it will work. So as we can now see that what mistakes we can make in the real times, right? So this was the main issue that we can miss in a hurry. Now this was the big O of n approach. So now wait for a while. So yeah, let us now move on to the second approach. So in the second approach, we will be doing the big O of 1, right? So yeah, so what we discussed that we'll be only swapping the values of the and initial pointer and the after that we'll be normally shifting the values. That means yeah, so that this is all. Now we will do the swapping. There is some error again. Yeah, so we missed the I will submit it. Yeah, so as we can see that I got my answer submitted by in this big O of 1 time. So yeah, this is what about this is all about this live stream. So I hope you guys understood this concept of linked list and the very basic question on linked list. And sorry for all the delays this live stream had, because this all the delays not usually happen in all the live streams, but there were some technical issues today. So sorry for that, and I hope you guys enjoyed this video and stay connected to practice channel of Geeks for Geeks for more such informative videos and more such recently asked questions on in many top tech giants companies. So yeah, guys, stay tuned. Happy coding.